one of the things we've been talking about so far this year, on and off in little bits along the way, is rounding. But all the rounding we have done so far, I've said round the number to 1 decimal place, 2 decimal places, the 4th decimal place, whatever. It's always been based on a number of decimals. Today we're taking a look at the vocabulary for those decimal places, because this is sometimes the trickiest part. Now, this problem that we're taking a look at here is asking us to round the number to the nearest hundredth. Sometimes we don't remember the names for these decimal places because we don't know why they're named that. So this fraction right here, how would you actually read this fraction? We could read this fraction here as 1/100th. Okay, so this is 1/100th. Now, what is that same fraction as a decimal? If we calculate that as a decimal, it gives us 0.01, which still means 1/100th. This is why that second decimal place is called the hundredth place. Because if you take 1 and divide it by 100, that's what you get. You get a number that's just sitting in that second decimal place. All of these other decimal places come from the same thing. And so, for instance, the 10th place here, it's called the 10th place because we get it by doing 1 divided by 10. It's 1/10. And so on for all of these different places. Now, because this vocabulary is often just what trips us up, take a moment, write this example down with its labels, please. And here also you end up with a bit of a glimpse into kind of my methods of teaching in this class. Because we've already been working with decimals and rounding decimals, right? But I had always just been giving you the named place value because, or the numbered place value, like first decimal, second decimal, etc. Because I wanted us to focus on how do we actually manipulate the numbers. I didn't want you getting confused about, okay, now I know I'm manipulating the numbers, but wait, which spot am I supposed to round to again? It's a one thing at a time way of doing it. So if you know how to do what we did today, you'll know how to do what we do tomorrow when we add one more layer to it. But I'm generally going to try to avoid ever giving you like 2 or 3 different layers for the same type of thing on the same day. You get one thing down, master it, then you're ready to take on the next thing. And so I know you can already do all the rounding problems that involve these terms now that you have the terms, because you've already practiced all the rounding rules. It's just now being associated with these words instead. Now, of course, I made up this number up here to illustrate, okay, in the first decimal place it's called this, and the second decimal place is called this, and all that. But of course, those same names work no matter what the number is. It's just a matter of how many numbers it is after decimal place. So it doesn't matter the number. There was nothing magical about that particular number or which numbers were in which place. So going back to the problem that I started you off with, we're rounding 85.79349 to the hundredth place. All right, so in this problem then, if we're going to round it to the hundredth, really the only new thing we're doing today is we're just having to remember where is the hundredth place. It's the second decimal. This question is asking the exact same thing as if it had said, round this number to 2 decimal places. And so the process is the same as what we did before. We look at the one next number and we ask ourselves, does it change our 9 or does it leave the 9? Well, this number here, it is less than 5, therefore it leaves it alone. So our final answer is 85.79. And we're done. That's it. It's rounded. Now then, shifting gears again. You've also been seeing a number of problems like these coming up on your wall map assignments recently. What two numbers add to this and multiply to that? And I've just kind of been throwing them at you, letting you figure them out, and letting you struggle with them some. The struggle is good. Yes, sometimes I'll let you struggle because we learn a lot through the struggling. But today I want to talk about a couple methods and a couple techniques because the numbers are going to start getting bigger on you over time, and I want you to be able to handle that. All right, now I am starting you off with an easy one. Many of you can probably just look at it and come up with it. But how do we know that? Well, whenever I do these, I'm always first looking at what the numbers are that multiply to the given number, rather than the adding. Because, and I mentioned this specifically, because some people will actually start with the adding part. Now, if I just started thinking of all the different ways I could add to 8, there ends up being quite a few different numbers that I can add to 8, right? How can I multiply to 15? 1 and 15, 3 and 5. Because we never have to worry about decimals with these. So notice, by focusing on the multiplication part first, we can see a lot faster which combination is the winner. Because there's only 2 options. I just have to decide which of those actually adds to 8. Well, that's easy enough, right? You list out your possible ways to multiply. There's our answer. So the answer here is 3 and 5. Those are our 2 numbers. Just want to practice this a little bit so I can continue giving you that insight into thinking. Go ahead and write down and do this problem, please. All right, so in order to attack this problem, I'm focusing on what numbers multiply to 30. Now, some of you looked at this and you knew instantly. Great, you know your times tables really well, you're flowing with it. I like it, that's good. But what happens if you don't? Well, if you ever aren't sure, list out the different ways to multiply to 30 systematically. So like I start at 1, and then I go to 2, and then to 3, and then to 4. Well, 4 doesn't work. Okay, so I tested 4. It gave me a decimal, so I don't need to do it. Then I go on to 5, and I keep doing them all until I would end up repeating myself, you know, like now it's 6. I already did 5 and 6, so I don't need to do that one. And so then those are all the different ways I can multiply to 30. You then just add them up, and then you know exactly which one adds to our desired result. So your answer here ends up being 5 and 6. And no, the order I give that answer in does not matter. If you wrote it as 6 and 5, same thing, perfectly fine. There's nothing magical about the order. Continuing with our patterns here. How about this one? It adds to the same number, but multiplies to a different one. All right, and we're getting quick on these now. So in this case, I hope that you came up with an answer of 3 and 8. Go ahead and write down and do this last problem now, please. Now, many of you will have jumped to the answer pretty quick. You will have seen it's 80. Whenever I see a number that ends in a 0, I always start by checking to see if the combination with 10 is going to work. Hence why the 8 and the 10 works. And so then you would have tested 8 and 10 at the very start, and yes, that ends up working. The 8 plus the 10 here ends up being our best solution. But I want to show you something just because I want to give you one more tip, because I'm going to be having you do a bunch of these here pretty soon. And I want to focus your attention at the start on them. For the first problems that I have you doing and the types that you're going to be doing, practicing this stuff today, I'm not going to be giving you any combinations where any of the numbers are more than 20. Okay, they're all going to be staying in kind of that times table area. You know, that multiplication table that you would have memorized, like back in 4th grade, at least theoretically. We're staying within that kind of an area right now. So this not only gives us a chance to practice this process, but also practice our multiplication tables. Because, yeah, the more you know your multiplication tables, the easier math gets. And just in case you're curious, why am I having you do this? Well, I would be happy to give you these types of problems just on their own because they build up such a great number sense and help you really get to know your multiplication tables, and that alone creates a lot of success later in math. But even beyond that, later on this year, we're going to be using the same technique of what adds to this, multiplies to this, to factor quadratics. So we're going to be using this same technique to take something that would have been written as x squared plus 18x plus 80, and we're going to be turning it into x plus 8 times x plus 10, because those two expressions are equivalent. You don't need to know that now, but it's just kind of a preview about why are we learning this now. Now the last piece we're going to take a look at today is a few patterns. Because thinking in terms of patterns in math is actually all we do. And so the more I can bring in patterns and get you thinking about those, I figure the better off it is for your brain. So go ahead and write down this pattern and go ahead and complete it. I think you got this one without too much guidance, right? All right, so we're taking a look at the patterns, partly just so I can have an excuse to talk about strategies when dealing with patterns. One of the first strategies we ever learn with patterns is we look to see, am I adding the same thing each time? And so I would check that here. 3 plus what is 10? 7. Okay, 10 plus what is 17? 7. And I keep going along and I make sure that yes, that works for all of them, because just because it works for 2 doesn't mean it's going to work for all of them. And it does, which means that if I want to get to my next term, I add 7. And so my next term is going to be 38. And then I add 7 to that one. And so the last term then is 45. Okay, nice. Next pattern, please. All right, so then we see another pattern, and we start by checking to see what can I add each time. That adds 3, that adds 6, that adds 12. We're definitely not adding the same thing each time, right? And so there's a couple different ways you could look at it. Some people are going to see, oh, I'm adding the same amount as whatever I had last. Yeah. Although normally we don't think of it that way. Normally it's a little bit easier to actually think of it in terms of what am I multiplying by then? Because if I'm not adding the same thing, I'm hoping I'm multiplying by the same thing. Well, 3 times 2 would be 6. 6 times 2 would be 12. You'll notice that each time I'm just multiplying by 2 here. And so we could just keep multiplying by 2, which would give us 96 and then 192. So check what you can add with. Check, then multiplying it. Can I just multiply by the same thing each time? So those are kind of the 2 basic skills. But of course, we're in high school now. We've been seeing these types for a while, so you know I'm going to start adding some complexity to it, right? So go ahead now and write down this pattern and complete it, please. So, based on what we've talked about before, you might have started by saying, well, what can you add each time? Well, 16 to 25 would add 9. 25 to 36 would add 11. 13, 15, 17. Well, there's kind of a pattern in that, right? And you could probably extend that pattern out to do it. But that one's kind of weird. It's not as consistent, but you can use it to get there. But I want to make you aware that there's actually another pattern involved here that maybe you didn't recognize at first, but I want you to start recognizing. Because each of these numbers that's listed here is actually a very specific type of number. 16, 25, 36. Ones that really tend to stand out in this regard are 25 and 49. All of these numbers here are perfect squares. So you'll notice 16 is actually 4 squared. 25 is 5 squared. And so all of these just end up being perfect squares. One of the types of patterns that you're going to see a lot in math, and that actually when you start to recognize them helps you actually learn math and see how to do things, for instance, graphing a quadratic function, is these special types of numbers. For instance, this case it's perfect squares. Another day it might be like prime numbers, something like that. But you want to be looking for some of those known patterns. And so then, if I'm going to complete this pattern, I know I'm just going to have to do 10 squared and 11 squared. And so this basically then, this pattern becomes a list of perfect squares. And yes, you should know your perfect squares because they come up in a lot of ways, including that graphing that we've already been doing, as well as other ways you haven't even seen yet.